welcome everyone to a groundbreaking moment in electric vehicle education. Today, get ready to delve into the future as we introduce the revolutionary ConsuLab EV-400 high voltage safety trainer. The EV-400 isn't just a training aid, it's a bridge between classroom theory and real-world application in electric vehicle technology. With the EV-400, students experience hands-on learning with a genuine 400-volt DC voltage, mirroring the high-voltage systems found in today's electric vehicles. It's the ultimate in immersive education, minus the risks that usually come with high voltage. Beyond mere voltage simulation, the EV-400 allows students to test and diagnose critical safety features such as the high voltage interlock loop and isolation systems. These are the backbone of EV safety and maintenance. No more anxiety about working on live electric vehicles with the EV-400. Students can confidently delve into the high voltage systems, reinforcing abstract concepts with practical, risk-free activities. Now let's look at some of the highlights. Realistic training for real-world scenarios. Hands-on experience with industry-standard safety systems. Critical understanding and maintenance of EV components. Practice high-voltage management without real-world risks. Visualize phase sequencing with integrated LEDs for enhanced understanding. Compact and classroom-friendly, facilitating easy integration. Engaging visual, auditory, and tactile experiences for optimal retention. Whether for individual exploration or group learning, the EV-400 offers versatility. Opt for individual units or a classroom set of 12, complete with convenient storage case. Each trainer comes bundled with a comprehensive user manual, schematics, student activities, and an instructor guide. Everything you need to embark on your high voltage learning journey. We've only scratched the surface of what the EV-400 has to offer. Stick around for a live Q&A session where you can dive deeper into this revolutionary training system. Your questions, our answers, are coming up next. And we said we were coming up next, and here we are. Welcome to the future of high voltage safety education. This is a pretty exciting day for us. We're glad everybody has tuned in to watch the reveal of the EV-400 high voltage safety trainer. I'm Jimmy Dinsmore. Joining us are members of our education team. We have Al Santini, remote from his house. And in studio, we have Dave Giles and Nathan Bankey. And of course, we know all of you are going to have some questions about this revolutionary new product. So we would ask that you go ahead and drop any questions you might have along the way in the sections comment, and we will get to all of those. But before we do that, as I mentioned, Dave and Nathan are there in studio, and let's take a first look at this product. Take it away, guys.
So here we have the EV-400. Like you saw in the video, it has all the components that we normally find on an electric vehicle. So we have all the control area, the high voltage distribution, the motor, the battery, contactors, disconnect, and of course the DC-DC converter, cabin heat, and air conditioning compressor. And this all reacts just as it would on the vehicle. So if we put our foot on the brake, press the ignition, it's going to power up, our contactors close, there we're gone, and we have the ready light on, and we're ready to put it in drive and start accelerating. It goes a lot further than that because we have fault insertion. We have 10 different faults plus a defective component that we can insert into the product. There's a complete high voltage interlock loop and high voltage isolation testing throughout. So there's a huge amount of different student assignments and exercises that we can do with it.
As well as the unit also demonstrates some of the complexities with an electric vehicle, like your pre-charge circuits, your first responders loop, and it integrates this into a system that's laid out very much like many EVs out there.
Well, let's go to a question we already have right off the bat. There's a question about if there's any kind of certification that comes with this trainer.
Yeah, so absolutely. We're really happy to announce that the ConsuLab EV-400, when combined with the required prerequisites, with the included student assignments and practical exercises would allow an instructor or technician to complete the CSA Group Automotive Electric Vehicle Technician certification.
Yeah, and this is a national accreditation. Once a student or a technician writes that exam, they'll be entered into a national database that's actually look-upable to see their certification level with high voltage safety.
Here was a question we had from Facebook. What kind of safety equipment or PPE is provided? Do somebody going to need anything else along with this?
So this is a great question, and one of the decisions we made with the product is that it is a turnkey solution. So each one of the EV-400, when it ships, comes with a set of large gloves, like I've got here, along with an included Pico isolation meter. So right out of the box, you have everything you need to work on this and be safe. We don't provide the safety glasses, but we figure you've already got them. So with the set of gloves, with the isolation meter, and with your safety glasses on, your students can get right in working on this in a safe manner.
We do have another question. Let's see. This is a good question here for Al, because somebody wants to know about the labs and curriculum that are available. And I can tell you that that guy there has been working hard on developing the curriculum.
Yeah, well, let me go through it kind of quickly. The curriculum is divided into 3 sections. The first section is safety, and the second section is the low voltage control circuit, or HVIL, interlock loop. And then the third section is the high voltage. Within each one of these sections, there are 4 pieces to it. They all start with a short intro, which includes theory, and then there's a quiz, and they have to get a good, decent grade on a quiz before they can go to the student activities or labs. And then we end each section with a test. So, this allows an instructor to assign specific things to specific groups of students and realize that everyone will be doing the same labs, not necessarily in the same order, but in the same during the same labs in the same sections at a time. So 3 sections: safety, HVIL loop, and high voltage.
That is great, Al. So we actually have a question here live from YouTube from Reed Mundy. He said, could this be used to help teach voltage safety on EV charge stations? And if so, please elaborate how. I'm going to probably toss that to Dave, probably.
Yeah. So essentially the charge stations, depending on level 1 or level 2, are basically level 2 and level 1 is basically supplying AC voltage to the onboard charger, whereas the level 3 is direct current directly to the high voltage battery. Currently this product doesn't involve the high voltage charging system. We're actually something we're working on as another product, but in the sense of the functionality of what the battery does, the interlock circuit, as well as the high voltage service disconnect, is also a very important part of that system. So understanding that the vehicle has to be in a proper state in order to accept a charge, this trainer actually will demonstrate that throughout.
Absolutely.
Somebody want to know if there's a way to do isolation testing?
Absolutely, and that's something we can do live. So we can talk maybe about some faults. I think, Dave, there was a fault that you wanted, so let's just go back over. You guys can see, I got my gloves on. If we grab the meter and put our leads in, we've got...
Yeah, so we have the contactors are closed right now.
So we got 389 volts, 390 volts on the meter, so our system is up and live, our ready light is there, we can put in drive and go. And I know within the 10 different faults, I don't have them all memorized, but I know there's one, Dave, that is an isolation fault that then we can go and find.
Yeah. So the beauty of this trainer also gives lots of areas for the isolation testing. Just like you would on a vehicle, you can isolate components from other systems to do the testing. But one neat thing about it is there is a fault insertion up here. There's 10 different faults. They create different scenarios. They go from fairly easy from the low voltage system to the high voltage system with very complex type of diagnosis a student would have. So I'm going to put a fault in here right now, and I'm just gonna set this fault, and from that fault, everything looks like it's working normal. There's a high voltage system fault,
Okay.
basically waiting to happen, and of course, when we go to turn on,
So
our climate.
I'm gonna go through like as a student or as a driver. I can drive the car. I can put it in drive, accelerate, and if I turn on my heat, oh, it's the heat. I'm gonna guess because if I turn on my heat, all of a sudden the contactors are now off. I've got an isolation fault, a high voltage fault. So now we can do just like we would on the vehicle. So I'm gonna put in park. I'm gonna turn the ignition off. I'm gonna take my isolation tester, put this into
Yeah,
isolation
and we're
test
gonna
mode.
take we're gonna turn the key off.
Yeah,
So I'm gonna do
take the
this here,
key
I'm gonna
out.
turn the key out.
Put it in the cage.
Yeah, so we have a protection cage from our transponder style key.
Yeah. Then I gotta disconnect the battery.
Yep,
I'll
12 volt
disconnect the
battery.
negative of the 12 volt battery, the positive of the 12 volt battery. Now what's really interesting is what we've added is 2 connectors for each of the components, or there's a harness. This represents the harness. So if I remember correctly, it was on the AC.
No, it was
It
on
was
the
on the
heat.
heat. It was on the heat. So if I disconnect the heat here, I'm disconnecting at the component side. If I disconnect it here, I'm disconnecting here at our high distribution, high voltage distribution. I'm going to disconnect it on the component side. I'm going to do my insulation test. So I'm going to put my positive lead here on the high voltage positive. I'm going to put my negative to chassis. And now I'm going to push and hold, turn this to the insulation test, turn on the light. You guys can see I've got my meter set up here. I'm all good. I'm going to press and hold the insulation test. And now we're pushing 520 volts through. We've got 0.2 mega ohms.
So we have, so now what I wanna do is check the negative side.
All right, so I'm going to swap over to the negative side.
See
I'm
if
going to
it's-
redo my insulation test. Here I've got OL, over limit. So I'm pushing 500 and some volts through that, and it's all good. So one side, my diagnosis as a technician would be on the negative side here with the component disconnected. I have good insulation, good isolation on the negative side of the high voltage of the cabin heat PTC, but on the positive side, I don't.
That's right, and if you wanna show a little bit further, I can open the connector on the air conditioning side, and
Yeah.
Nathan now can put the leads on
So let's
that
do the
side
same
and actually
test.
do the test.
So on my positive side of the AC,
So we have, good.
well, and on the negative side,
And that's the beauty of this trainer, is that
there we go.
it simulates, you can even go and test prove other systems that didn't have the fault, but to actually apply the voltage to do that isolation test. And right now we're at 530 volts, or about 500 volts on this isolation test. You can go all the way up to 1,000 volts on this unit with no issues at all.
Yeah.
So it's protected. If a student happens to put 1,000 volts on a component that's calling for 250 volts, part of the isolation, it's not going to hurt the unit. So
One of the really challenging things in developing the product was you'd give your students some gloves and a multimeter, and now you let the students loose on this product you just developed, and you give them 1,000 volts, and now they can poke and prod anything on here on the top side. So Meg, this would be a great time to show the image that we've got, just a little snapshot of what's under the hood. This is one of our colleagues here in engineering who's been working on this, and let's just say there's a lot of time and thought and energy that went into the development of the product that shows just how well protected it is that I can take 1,000 volts and I can poke and prod anywhere on here, right to ground,
yeah.
right to chassis, and none of the smoke's going to get let out of this thing.
Yeah.
It is very, very well protected.
So the way it's designed is not just jumper wires and cables and so on underneath. It's a very logical and logistical way that it's been put together, designed, and how it functions. And we really did a lot of research with our engineering, with our education team and industry on, you know, what they would like to see in a high voltage safety trainer. And by bringing that all into this one package, allows the student to experience just right from a drive mode to a diagnostic mode, a service disconnect, you know, the functionality and power flow through an EV system right in front of them. And doing it safely.
And
Alright, next question, sir.
we got several. So this one I'm going to throw to Al because I know he's very passionate about this topic. Somebody asked, should students have a basic understanding of AC and DC before they even start messing around with this?
Yeah, I think so. I mean, it makes sense because you might say that this is if you put it in stages, we're going to start somebody out on probably 12 volts, and once he gets good, decent with the circuitry and everything, and understands the basics of a 12-volt system, then it makes sense to start moving him into more advanced things. And typically, that's where we would go into the ignition system, or we go into the fuel system. Well, this is another system. So, in other words, we would go into EVs somewhere down the road, but we're not going to do it right away, I don't think. I think that would be a mistake.
All right, we've got a question whether, and I know we were talking about this before about the DLC and how some EVs on the road do have those and some do not. So the question is, does this trainer have a DLC?
So the product does not have a DLC. What we've chosen to do, because numerous different manufacturers are no longer putting data link connectors or standard data link connectors on their EVs, and also because we've designed the product in a very generic nature. It's not a Nissan Leaf, it's not a Chevrolet Bolt, it's not a Tesla. It is kind of an amalgamation of the features of all of them in a very generic manner. So if we look here, we can see we have 4 different types of fault indicators. So here we have 12-volt faults. We have interlock faults, high voltage fault, and isolation fault. And in our education department, we determined that with that indicator, we're giving the students enough diagnostic path when we've taught them and given them the theory on diagnosing an interlock fault or a high voltage fault or an isolation fault, and seeing the combination of which faults light up, they will be able to establish their diagnostic path, go through with the meters, test the system, and work by deduction and find problems. So we've had great success in doing that.
Yeah, and it's also important to note as well that this trainer is designed as a tool to help students use these types of tools. Use a multimeter, use a milliohm tester, use a lab scope, and this trainer allows you to do all these different types of tests on this one unit, but not being, like Nathan says, not being directly tied to a manufacturer. So it gives the students lots of practice, even from the service disconnect, what it does, how it works, for the first responders loop, what it does, how it works, and gets them also to practice using the PPE, like their gloves and so on, and understanding how it feels and getting those readings of a real 400 volts.
So really, this, we like to think of it as a way to bring the students to the next level faster. Let's have them practice, do all their measurements, do their fundamental diagnosis here, and then we can let them loose on the vehicles, whether it's on a ConsuLab EV-601 iDev Tesla or on one of your EVs in your shop. Have them practice here in a controlled environment, and then we'll get them to drop in the battery soon enough.
It's funny you mentioned the EV-601 iDev Tesla, because we actually had a question, and they know we just launched that product and it's doing very well, but they were wondering how this would work in correlation with the Tesla car.
They fit so well together. It's almost like we planned it for the two of them to work together. What we teach and demonstrate here, in both directions, the students could learn about the basics on the Tesla in understanding the systems at the big picture view. And by the way, to come back to the question about charging level 1, level 2, level 3, and teaching that combined with the thermodynamics aspect, those are all subjects that we cover on our Tesla iDev. So that's the interactive development electric vehicle that we have with all of the touchscreen, the LEDs, and all of those features. So both, if the students experienced the fundamentals there, or if they were to start off on the EV-400 high voltage safety trainer and then move along to the Tesla, both paths would be great for the students. There's very little overlap of what hands-on you can do between this and what you can do on the Tesla. So they're very, very complementary products.
Yeah, including in the curriculum too. Like, this is a very testable, high voltage, live, ability to demonstrate different things within the high voltage system, where the IDEV or the 601, EV-601, is a vehicle that shows a lot of the fundamentals like charging and how it works, and the thermodynamics. You talk about coolant flow and the battery location and the motor drive unit and what it does and all these different things. There is a different product than our EV-400, but they do supplement themselves very, very well.
Dave, a couple of minutes ago, you mentioned first responders. There was a question about how this would be applicable to first responders.
Well, it's really good because it demonstrates, one, what happens when the first responders loop is disconnected, what dies, what stays alive. And this is a big challenge for first responders because in the event of disconnecting the first responders loop, what actually systems are depowered on a vehicle with the first responders loop. So, and this allows to still, once again, see that we still have active systems and we have other systems that are not active. And that's what's really great about this product, as well as through instruction, they may also be instructed to do something with the service disconnect. So a first responder understands what that looks like and what it actually does. When you disconnect the service disconnect, it doesn't kill the vehicle's power. The power is still in the battery, but it changes that power in the battery. So they can actually measure it and see it. But also, which is even really cool with this, a first responder can learn how to operate an electric vehicle. So they can actually go in, start it, put it into drive, put it into reverse, see what happens within the power flow of that system. So it's a really great way of showcasing the electric vehicle systems in this unit to first responders. And this includes fire, police, and medical as well.
So while Dave was explaining that, I disconnected the first responder loop here. So I had the vehicle on, we were driving. And of course you wouldn't disconnect it while you're driving, but disconnect it so that the contactor is then open, and then we're very easily able to show that the low voltage system is still live. So the battery, there's still 12 volts flowing through your infotainment, everything else, your power steering's on. There's still the inherent danger in the battery itself. It's still got 390 volts, but everything else in the system, we have an interlock fault and a high voltage fault. So everywhere else in the system that could be accidented or damaged is at 0 volts because the system is now off. So we can demonstrate that, teach that, diagnose that with first responders very easily using the EV-400.
Yeah.
There were a couple of people asking about price and everything. We're not going to go into price here on this video. The price is set. We are ready to quote it. What I will say to anybody is, I'm sure many of you are interested in this. If you are, reach out to your ConsuLab sales rep, or you can always email sales@consulab.com. We'll be happy to get you a quote with the price. All of our price is locked in for 12 months, includes shipping, includes the curriculum. The curriculum is available on our website, and it also includes the cards and the picoscope as well, all included in the price. Also, there was a question about whether we would do some kind of product training if someone bought that.
Mm-hmm. Absolutely.
Yeah.
So we're prepared for that. We're ready for that to do product familiarization training. In fact, soon enough we'll be filming the familiarization videos for this product. So all of that is going to be available to get trained up on how to use EV-400 in your classroom.
Yeah.
Jimmy, we're also going to be, we'll be showing at some of the conferences from this point on. NACAT, for instance, it's going to be there. The MTT at Minnesota teachers, it's going to be there.
Yeah.
I think it's going to be in California. It's going to be, so you'll be able to see it at various conferences.
That's a great point, Al. And it's not just to see it, is that at many of these conferences, we already have the training sessions planned and booked. And Al will be one of our technical trainers. Al, Dave, and others on our team will be out on the road with multiples of these units to give training at these local conferences. So you'll have a chance very soon to get out in front of one and get training on it with Al or Dave or someone else in the team.
And what's really cool, we'll have this at the ASE conference, but also we're going to have the EV-601. So so we'll show how the two units integrate with each other. So
That's right. Coming, let's see, two big summer conferences in July. We've got the National ASE Conference in Minneapolis. Dave will be there, like you said, along with the EV-601 and that. And then I think it's actually the very next week is NACAT, where Al and I will be there. We will also have the Tesla car, and we will have the EV-400 to demonstrate there. The best way to get even more excited about this is to just get your hands on it and play around with this. Can you talk a little bit more about? There was some confusion about like the safety. Is the 400 volts just simulated? I mean, how do you ensure that students aren't
Well, let
getting?
me.
I don't have jumper wires, and I'm not going to lick
But
the
you
wires
can't
today.
you can't get killed from. It's 400 real volts of meters. All your equipment will identify as 400 volts, but the difference is that there's very little current. Like there's almost no current at all. So it is 400 volts, but it doesn't have any current. So if a student does touch the cables or the wires accidentally, but typically with process and procedures, they're required to wear their gloves and have their proper PPE while using this demonstrator. But if they happen to inadvertently touch something or do something, it's just a minor, it's almost like a static shock, I would say. If you're pushing a grocery cart and you get that shock, that's probably the amount that you'll feel.
So you can short out the 400 volts together from the high voltage positive to the high voltage negative, and the system detects that.
Yeah, it'll set a fault, yeah.
And then you can also short from the high voltage positive to the chassis ground here, or to any metallic part of the product, and it shuts down. And the amount of current that is flowing is of no danger to a human.
No.
So there is no risk of injury to anyone. We're in the process of getting the product certified for electrical standards, so that this product will be certified with a CSA group certification. So it's 100% safe.
Yeah, and that's important for schools as certification on the product as well. That's way you know that it has met certain standards, it met safety standards in order to be used as a demonstrative tool or a training tool within a classroom. So.
We are through all of the questions, but I think people were a little uncertain about some of how you troubleshoot some of the codes and everything, because I think some people are still used to just a DLC, that they want to understand a little more about that.
So let's give some examples then. So for example, we have the system on. So I have 400 volts system voltage. The two contactors are closed. I have my ready light on, so I'm ready to drive. When I put in drive, I can accelerate, I can brake, we can see the three phases there. The system is fully functional. Dave, do you have an interlock fault to demonstrate? Or I can show
Sure,
another
let's
one.
do number 2, yes.
Number 2, so that's an interlock fault?
Yeah, this is part of the low voltage system.
Okay, so this is an interlock fault, and now we don't know where the interlock problem is in the entire vehicle. It could be anywhere. It could be a broken wire, a bad component, chafing somewhere that caused it to detect and open. And the interlock circuit works essentially with a voltage supply, and it goes in and out of every single component. I've got no voltage now, so I'm going to take my gloves off and show this. So the interlock on each component is kind of like a little pin. Looks like two pins right there in the middle, and on every connector we have that it runs through.
Yeah.
So now we have to diagnose the break in the circuit. And I know Al, in the student assignments, he's got this set out. We have schematics explaining and showing how the interlock circuit is configured. So then it becomes a question of voltage drop testing. So I'll set this up for voltage. You're on voltage, Dave, if you want to go through the
Sure.
voltage
So
drop.
what I'm going to do is very similar to, so the layout of this tool, this training aid, is designed the same way as a manufacturer would be able to sense where the fault was within the system. So we've done it the exact same way. So right now, if I go through each of these components, I'm going to see the applied voltage to the interlock fault. We have an interlock fault, which means we probably have an open in the circuit or a short in the circuit. But right now, with me seeing 4.7 volts, I'm just going to go through the components of each interlock here. And I'm going to see the 4.7. And typically, I can show this after. I wouldn't have 4.7 at each component with a completed interlock circuit because I have voltage drops over each of the areas. So I'm just going to go through each one, and we keep seeing our applied voltage. So I'm just going to keep going through. And of course, once I find the fault within that system, I'll know because my meter will go over here, and we got 0, and then every other interlock after it would be, because now I know where my open circuit is. It's within the DC to DC.
So if we take the fault off, now we can demonstrate for them.
That's
for
right, yeah.
everyone. So normally we'd have 3.4, and then these voltages all add up. So
Yeah.
we're going to go in reverse order. We're going to go from 3.4.
3.4. Yeah, so as we move through the
So we
interlock
lost
circuit.
400 million.
Yeah, that's right. Oops. And then as we keep going through, we keep seeing the voltage changing as we move through, because we're working on through each of the interlocks here, or the loops here within that circuit, all the way to the final one. So it gives the students an idea that this is a series circuit, you know, involving the high voltage service disconnect with each of the components being plugged in. If any of these components gets open, if I open up the service interlock, or if I open a connector, it'll instantly throw my interlock fault there, which means that there's a fault within that system. So
Exactly. So that's a great example of how we would diagnose and how we will teach the students to diagnose interlock circuit fault. So let's get this back to 0, and let's maybe talk about isolation faults. We did one earlier. We showed how to diagnose the isolation fault. Let me mention one other thing. We also have, hold this up and show it here, we have a defective component. So we chose to use switches everywhere in the system except for the disconnect and for one harness. And that was very strategic. We wanted to be able to have enough space to fit this in the package we wanted, and having 10 of these connectors repeat themselves would take up a lot of space. But we kept this one here, and that means we've developed a defective harness. So we can actually put this harness in, and the trainer will detect an isolation fault. It'll trip the high isolation fault and a high voltage fault, and now we can go through and diagnose it. And we can even repair the problem. So the students can isolate the problem specifically to these two wires, one of these two wires, and tell you, this is where my isolation fault is, just like if it was on a car. Then you can give them their nice brand new harness, they plug it in, and now they can get the car working again. So that's the level of diagnosis that we want to be teaching with this product.
And it is a testable product. That's why I keep emphasizing, is that the whole idea is that the students get a chance to actually use logistical routes to locate problems within the high voltage system. A DTC may say a high voltage fault in a component, but they still have to go through the harness, a component, even the power distribution, isolate these components, test them individually, and the 400 copies that exact type of scenario that would happen on an actual vehicle.
So that defective cable is included as well, yes?
Yes, this is included with the product as well.
So then I also want to make sure everybody's aware we will also be offering these in what we call a classroom set, which is a dozen of them, and they also store away in a storage cabinet that you can wheel in and out of your classroom. Anyone who has our very popular or most popular Ohm's Law trainer, it's the exact same storage cabinet, works the exact same way. In fact, we designed it with that intent, so it's the same type of briefcase, right?
It's the same size, it's the same case, it's the exact same layout as the Ohm's Law trainer. So if you have Ohm's Law trainers, they'd slot right into the same case.
Excellent. I believe we have all the questions answered.
That's wonderful.
Yes. So again, this product will be at many, many, many conferences coming up. We have it available now. All information will be up on our website on the EV-400 by the end of the day. Go to ConsuLab.com, and in the search box, just type in EV-400 and the spec sheet, and all information on this trainer, along with additional photos, will be up. I also encourage you, you're watching us on YouTube. If you aren't already, go ahead and click the thumbs up, like, and subscribe. You know how it all works. This video will be residing up there. And if you haven't done so, we've been conducting a whole series of EV webinars on various topics over the last several months. from members of our education team, and we have an entire playlist of those EV webinars because we want to be your partners throughout the EV process here. It's definitely not a fluke. Whatever your opinions on EVs are, they're out on the road, and your students should be prepared to work on them, whether they like EVs or drive them or not. This is part of the industry we all live in now. So, well, does anybody disagree with that? No. In fact, we have 1, 2, 3 EV owners right here. Nathan, Dave, and Al all own an EV now. So,
What are you doing, Jimmy? Come on.
Yeah,
I mean,
Jimmy.
I drive a lot of them. So, all right. Well,
Thank you, everyone, for joining us.
Has anything else?
No.
Yes. Excellent. Thank you, everyone, for joining us on this exciting product launch.
Awesome. Thank you.
Thanks,
Have a
everyone.
great day.
Bye-bye.